So we've been working with substitution in indefinite integrals, and we're going to encounter a couple problems that look something like this. And so I want to talk you through the process in the process show you how to tackle these problems that have natural logs in them. So our strategy is to choose u because we want to deal with this composition. So your tendency is to choose the thing in parentheses for the u. In this case, though, those parentheses, that 7x in there, it really doesn't impact the problem. If you choose that for u, you're not going to improve your situation because the derivative of 7x is just 7. It won't cancel out the other x. So my advice to you is whenever you're choosing u and you have a natural log in the expression, try to choose the natural log part. So I'm going to choose u to be natural log of 7x. The next step, so this was step 1. Step 2 is to take the derivative, du over dx. So as I pause to write out derivative, the du over dx here, that's going to be 1 over x. Remember, our formula for the derivative of the natural log of u is u prime over u. So that's 7 over 7x, which is 1 over x. And then step 3 is to solve for dx. And so when we do that here, we multiply by dx, multiply by x, we get dx equals x du. Okay, so we've done this because we want to replace the natural log of x and the dx in our original problem with u and x du. And so we rewrite this, we create a new integral. So instead of this integral here, we're transforming the variables, and we're going to put u where the natural log of 7x is. It's still over x because we haven't dealt with the x yet, but we're going to replace dx with x times du. And as it turns out, that is great news because with a little extra simplifying here, these x's cancel, and I've changed the original integral, which was the integral of the natural log of 7x over x dx, to this new integral, and I'll use the yellow again to write this out, which is this, the integral of u du. And so this is, a power rule problem. And the way we solve a power rule problem is our formula. It'd be u to the 1 plus 1, so u squared over 2, plus c. Don't you dare forget that plus c. This is an indefinite integral, and we have to have that plus c in there. So we're almost done. But this is in u language, right? Our answer here is u squared over 2 plus c. We want to write our answer in x language. So all I'm going to have you do is substitute your u, natural log of 7x, back into this problem. So the way I would write the final function here is 1/2, that takes care of the over 2 part, natural log of 7x squared plus c. And this guy is the answer to this indefinite integral. So that's our process. Choose u, take the derivative written as du over dx, solve for dx, and then create a new integral that's written in the u in terms of u. Now, there will still be x's possibly in your expression, but if everything matches up, they'll cross out, and then you'll get to here, and you'll have that integral written in terms of u, and this should be one that you can quickly do. Right? This is just a simple power rule. We do the u squared over 2, we're good to go, and then we substitute the stuff back in. So that's the process for not only u substitution, but also letting you know that when there's a natural log expression in your integrand, I recommend that you make that your u. Because when you take the derivative, the natural log stuff goes away, and usually the other x's cancel, which is what happened here. So hopefully this helps you at least with some of the problems that we're doing later in our assignment. There'll be other videos where we practice some other substitution in indefinite integrals as well. If you need me, just let me know. You know where I am. Otherwise, take care.